Let's take a look at another one. The population of a town is growing at a steady rate. In 2016, the population was 52,500, and by 2020, the population had grown to 56,900. Write a linear model for the population growth of this town. So again, sometimes I like to start with a picture. You don't have to, but for me it's helpful. So here's the idea. The population of this town is growing over time. And so our x variable is going to represent the time in years. And our y variable is going to represent the population of the town. Now you have a couple of choices. We could use the years that are provided. So we could say in 2016, our x variable, the population was 52,500. And in 2020, the population had grown to 56,900. We could definitely do that and then use the point slope formula. First find the slope, use one of these points, write the equation of the function. Or something that's often done when looking at time is to make the first point in time year 0. Now, if we did that in year 0, in other words, when we started counting, the population of the town was 52,500, and then 2020 would be 4 years later. The population of the town was 56,900. And the reason some people choose to make that swap of the years is just to make the computation a little bit easier when you go to point slope formula. In the end, both of these will come out exactly the same. So whether you choose to do point slope formula with the original coordinates or you choose to do point slope formula with the second pair of coordinates, in the end, the linear function is going to be exactly the same. So let's go ahead and do this problem. So the first thing we're going to do is we're going to find the slope. I'm going to choose to do it with the second pair of points because it'll make the computations easier. The slope is the change in y, 56,900 minus 52,500. Divide it by the change in x, 4 minus 0. So let's take a look at what that would equal. 56,900 minus 52,500. Divide it by 4. That comes out to be 1,100. So in other words, the population of the town was growing by 1,100 people per year. And the second thing we're going to do is we're going to use the point slope formula, which I'll record right here, to write the linear function. And again, you can use either point that you'd like. What I'm going to do is I'm going to use this first point because I notice that it has an x coordinate of 0, which will make writing the linear function really easy. So the linear function is going to be y minus 52,500 is equal to m, 1,100, times x minus 0. And if you simplify that, we have that our population, which I'm just going to call p of x, is equal to 1,100x, the slope, plus 52,500, the starting point, the y-intercept. If we wanted to predict the population of the town in 2025, notice that time, year 0, was the year 2016. So in 2025, if we take a look at how far that is from 2016, 2025 from 2016 is 9 years. So to answer that question, we would simply put a 9 in for x. So the population prediction in 2025 would be 1,100 times 9 plus 52,500 And that comes out to be 1,100 times 9 plus 52,500. We would predict that that town, if it kept growing by the same amount each year, would have a population of 62,400. Finally, when will the population hit 62,000? To do that problem, all we would have to do is take our linear model and substitute 62,000 for p of x. That would give us this equation. 62,000 is equal to 1,100x plus 52,500. And then all you have to do is solve for x, remembering that x represents the time in years since 2016. All right, let's look at one last example. A salesperson is offered two starting salaries. Option 1 is a base monthly salary of $1,000 and 8% commission on sales. Option 2 is a base monthly salary of $1,500 and 3% commission on sales. Can you help this new employee choose the best salary option? Again, you don't have to, but I like to start with a picture. So I'm going to draw a picture of option 1. In option 1, he starts at $1,100 for his base salary, and it's going to grow by 8%. Okay, so this is option 1. In option 2, oh, let me fix that. He's only starting with 1,000, not 1,100. In the background, that's Mandy the dog, just in case you're wondering. Okay, for option 2, he's going to start higher at 1,500, but notice that he grows at a slower rate. So the first one grew at 8%, but the second one only grows at 3%. So it grows, but not as fast. So that would be a picture of what option 2 looks like. Okay, so here's the point. And remember, what is our x variable? X is going to represent the sales. So which salary should he choose? Mandy is making a choice. I'm not sure what she's picking, but she's definitely voicing an opinion. Okay, so hopefully you can still hear me. In this range, option 2 is better. And in the second range, option 1 is better. And the question is, what are the sales, how much in sales would we be making when the one option changes and becomes better than the other? All right, so we would have to then write a model for each one of these. So let's go with option 1. So option 1, your salary based on sales is 1,000 plus 8%. That's 1,000 plus 0.08 times x. For option 2, your salary is 1,500 plus 3%. That's 0.03x. And the question that we're trying to figure out is, when are these two the same? All right, so the question is, when is option 1, which is 1,000 plus 0.08x, when is that the same as option 2, which is 1,500 plus 0.03x? So why don't we go ahead and solve this, and we'll see if we agree with what Mandy the dog was barking at earlier. Let's see, but I think I understood what she was barking. We'll find out. We will subtract 0.03x from each side. That gives us 1,000 plus 0.05x is equal to 1,500. If we subtract 1,000 from each side, we have 0.05x is equal to 500. And if we divide both sides by 0.05, let me get out a calculator to do that. 500 divided by 0.05 gives us 10,000. So what that means is if the salesperson thinks that he's going or she is going to have less than $10,000 in sales per month, then option 2 is better. But if the salesperson thinks that they're going to have more than $10,000 in sales a month, option 1 is better. Mandy, was that what you thought? She's nodding. All right, Mandy's very good at math. Okay, so here's one for you to try. The population of a small town has been growing steadily. In 2004, the population was 6,200. By 2009, the population had grown to 8,100. Write a linear function that models the population growth of your town. So let me help you get started. You have two choices. You can use the given years and the populations. So that would be 2004, 6,200, and 2009, 8,100. Find the slope, use the point slope formula, or you can make it a little simpler by going 0, 6,200, and 5, 8,100. But then if you do it this way, x is going to represent the number of years after the year 2004. And in this case, the first one, x is just the year. All right, why don't you give that a try?